We've got two more L'Hopital rule examples here, and the first one is pretty straightforward. We're going to put the limit of 2 in. So if we put the limit of 2 into the top there, we get a 0 on the top. And if we put the limit of 2 into the bottom, we get 2 to the power of 4, which is 16. So we get 0 on the bottom. So it tells us we should use L'Hopital's here. So very straightforward. We're going to differentiate the top and the bottom, put the limits in, and see if we can get a nice limit. So when we differentiate the top, we get -1. When we differentiate the bottom part there, we're going to get minus 4x cubed. Let's now put our 2 into both. Well, -1 on the top. And on the bottom, we have 2 cubed, which is 8. And 8 4s are 32, and they're both negative, so it's -32 here. So my limit is simply 1/32. So that was quite a straightforward one to do. Let's have a look at another one. Now, I'm going to do this in two ways. First of all, I'm going to do this with L'Hopital's, because if I put in 3, you're going to get a 0 over the top and a 0 on the bottom. So we think we're going to use L'Hopital's. So we use L'Hopital's, we put in our limit, x is going towards 3. So we differentiate the top, we get 2x. We differentiate the bottom, and we get 1. Now we put in the 3. This gives me a limit of 6. But did we need to do L'Hopital's? It was quite straightforward, but what we could have done with this one is we could have looked at this and done something with our function. We could factorize the top and put it into 2 brackets of x minus 3 and x plus 3. And we can divide all that by x minus 3, and you can probably see where this is going. We're going to cancel out those 2 x minus 3s to leave me with x plus 3. I put that limit in and I get 6. So this was a very straightforward one to do without L'Hopital's. You can do L'Hopital's and it still works, but have a think whether you actually need to do it all the time.